Electrons are said to exist only in energy levels at absolute temperature K and have no movement. Does light travel regardless of temperature as long as there is space? It is a general physical theory that electrons exist only as energy levels and have no motion at absolute temperature 0 K, Kelvin. This is called absolute temperature, or absolute zero. In this state, electrons do not have even the slightest thermal motion and exist only as energy levels. Light is an electromagnetic wave that travels through space. It does not directly interact with the particles of matter and propagates in a waveform, regardless of temperature. Therefore, light can travel at any temperature if it is present in space. Electrons and light are two different physical concepts. Electrons exist at energy levels as part of matter, while light is electromagnetic waves that travel through space. These two have different properties and interactions, and they are not directly related to temperature. Additional details. The term energy level could be defined. An energy level is a quantum mechanical concept that describes the allowed energies of an electron in an atom or molecule. The concept of thermal motion could be explained. Thermal motion is the random motion of particles in a substance due to their temperature. The concept of absolute zero could be explained. Absolute zero is the temperature at which all molecular motion ceases. Summary. In conclusion, electrons and light are two different physical concepts that are not directly related to temperature. Electrons exist as energy levels at absolute temperature, while light can travel at any temperature. Can light be trapped or absorbed within a material? Yes, light can be absorbed or trapped by matter. This is an important physical phenomenon related to the interaction between matter and light. Absorption. Matter can absorb the energy of light of a certain wavelength. In this process, the energy of light is transferred to an electron within the matter, and the electron moves to a higher energy state. This absorption process typically occurs at a specific wavelength or energy range, and light of other wavelengths can pass through without being absorbed. This phenomenon is used in a variety of application areas, such as spectroscopic analysis and optical fiber communication. Reflection. Light can be reflected from the surface of an object. In this case, the light is bounced off the boundary between the object and the medium, and the direction of the light is changed. Mirror-like reflection occurs on a smooth surface, such as the surface of a mirror, and diffuse reflection can occur on a rough surface. Refraction. Light can be refracted when it passes through a medium. This occurs when the speed of light changes within the medium, and this causes the direction of the light to change. This phenomenon is used in optical devices such as lenses and glass prisms, and the light can be bent in different directions depending on the refractive index. Scattering. Scattering is the phenomenon of light being scattered in all directions by fine particles within a medium. This causes the blue color of the sky or the diversity of colors in sunlight. Therefore, matter interacts with light in a variety of ways, and these interactions play an important role in a variety of fields, such as optics, spectroscopy, lasers, and optical fiber communication. Additional details. The term absorption could be defined. Absorption is the process of a substance taking in and absorbing energy. The term reflection could be defined. Reflection is the process of a wave bouncing off a surface. The term refraction could be defined. Refraction is the bending of a wave as it passes from one medium to another. The term scattering could be defined. Scattering is the process of a wave being deflected in random directions by particles. Summary. In conclusion, light can be absorbed, reflected, refracted, or scattered by matter. These interactions are important in a variety of fields, such as optics, spectroscopy, lasers, and optical fiber communication.